Okay, we have 60 meters of netting. We want to build 3 adjacent rectangular cages. The 3 cages are to share 2 common walls. Find the dimensions x and y so that the total enclosed area is as large as possible. So let's draw a picture of what we're looking at. It's a rectangular area, and we have 3 cages. Now the cages don't have to be congruent. They don't have to be the same size. So you can have one medium size, one small size, and one bigger size. You can say, well, I want to move this over here, and there's my small, medium, and large. They don't need to be the same size at all. Because it's not telling us that the 3 cages need to be. So maybe we got chickens in one, and then we've got cows in another, and then maybe we have pigs in another. We've got a rectangular area that's got dimensions of x for our width and y for our length. Now, if y is our length, we're going to have y across the bottom and y across the top. And if x is our width, that means each one of these walls is going to have a length of x. And these are our 2 common walls. So let me just show you. They share 2 common walls. Here's a common wall and here's a common wall. Okay. We need to write a function of the area in terms of the width x. But they're giving us some information here about perimeter again. So here we have 60 meters of netting, which are going to build 3 adjacent rectangular cages. So I'm going to have my perimeter of 60, and that's going to equal, well, I'm going to have netting along all of the x's. So that's going to be 4 x's. And I'm going to have netting for both of the y's. So that's going to be 2 y's. And I can see that 2 goes into all 3 of those numbers. Actually, 4 doesn't go into all 3 of those numbers, but 2 definitely goes into all 3 of those numbers. 2 goes into all of those numbers, so we have 30 equals 2x plus y, just to kind of keep things simple. And it does tell us that we want area in terms of width, so I know I'm going to have to take this equation right here and solve for y. So I've got y equals negative 2x plus 30. Now we're going to write our area. Area of the entire rectangle is x times y. But we already know that y is negative 2x plus 30. So we'll substitute that in there. And now we have a function, area, in terms of x. I'm going to distribute. And now I need to complete the square. So I'm going to take out that negative 2. I'm just taking out that leading coefficient, minus 15x. Half of 15 is 15 halves. Square that and I get 225 fourths. Now that 225 fourths is subject to being multiplied by negative 2. So that's a negative 225 over 2. I'm going to add 225 over 2 to undo it. So we have area equals negative 2 times x minus 15 over 2, which we also know that that's 7.5, plus 225 over 2. The vertex, which stands for our input and our output, right? Input of x, our output of area. Our input is 15 over 2, which we also know is 7.5. And our area is going to be 225 over 2, which we know is 112.5. So our x is our width, and our A, our area, is our area. So the dimensions will be x by y. Remember that y is negative 2x plus 30. So we'll have 7.5 feet. Actually, it's meters, isn't it? 7.5 meters by, if I put 7.5 in for x into negative 2x plus 30, I'm going to have negative 15 plus 30 is 15. So 7.5 meters by 15 meters. So that's going to be the dimensions of the entire rectangle. So this entire rectangle will have these dimensions right here. And the maximum area that we're going to be able to get out of that is 112.5 square meters, or you can write meters squared. And that is our answer. Okay, we're gonna have a try for you. Here's a try. This time we have 4 adjacent rectangular cages. However, it's very, very similar. So if you just follow what we did on the last one, you should be good on this one. Go ahead and press pause, and when you're ready to check out your answer, press play. Okay, welcome back. Here's our answer. With the work shown, you should have gotten 8 feet by 20 feet. So I'm going to zoom in here. 8 feet by 20 feet gives you 160 square feet maximum area. Here's our work that we show to get to our answer. And that's the type of things that you need to be thinking about. That picture, I can tell you right now, the picture in these word problems worth 1,000 words. Yeah, the picture's worth 1,000 words. I think that's the saying. Okay, when you come back, we're just going to talk about products of numbers and finding a maximum product. So it looks like we're doing lots of maximums, but we can do the same thing with minimums as well. It would be the same exact process.